So let us try to understand an entire application code, right? So the first thing that we do is to include the mandatory driver file, right? So if you go to the boot support package, here we could clearly see that for our UARTLITE, okay, so both the instance of UART, that is UART0 and UART1, the recommended driver is UARTLITE, right? And that is what we included over here. So hash include x UARTLITE.h, right? So this is the first driver file which is required for initialization as well as usage of both the UARTLITE IP that we have in our block design. The second driver file, which consists of all the hardware related information, is an xparameter.h file, right? So these are the two mandatory driver files that we require. Then we proceed. Now we know that there are two independent instances of an UARTLITE which are present in our block design, right? And hence we need to perform initialization for both of them, and we know that to perform an initialization we required a config structure and an instance structure, right? So we declared a two independent config structure. For UART0 we have an UART config 1, and for UART1 we have an UART config 2, right? Similarly, we declared two instance structure, UART1 and UART2, right? Then we have an independent function which we referred as an UART init that will perform initialization for both the instances of an UARTLITE, right? So first we generate the config structure, that is by calling lookup config and specifying a device ID. So if you just go to an xparameter.h file, now we know that we named an instance of an IP as UART0 and UART1, right? So if you just search for an UART0, so you find out all the information related to a UART0. Similarly, you find all the information related to UART1. So we just required a device ID for UART0 and UART1, okay, and that we need to pass as an argument to a lookup config, right? So this will generate the config structure that we gonna utilize in a CFG initialize along with an instance structure and the base address to perform an initialization, right? Now this again returns the status of initialization which we are storing in status1 variable, right? Similarly, we perform the same step for the second instance of an UART. Then we are verifying whether both of this, that is status1 and status2, is equals to XST success, right? If that is the case, we are just printing UART init successful, else we print UART init failed, right? So this is what we need to do for initialization of an UART, right? So when we ourselves perform an initialization of an UART IP, okay, so we can just call an UART init over here. Now remember, here we need to keep an init platform because we haven't performed an initialization of a UART PS that is present with the Zinc processing system, right? And that is what we're going to use for debugging, right? So we have an independent UART PS, okay, which will be used for debugging, and the two independent UARTLITE IPs that we are connected in across so that data transmission from one to other can be verified, right? So this we require to keep in a main code, right? In a previous case, we are initializing an UART PS, so init platform is not required, right? Then what we're going to plan is when we transmit the data, okay, so this is our block diagram. So this we assume as a 1 and this we assume as 2. So whenever we plan to transmit the data from UART0 to UART1, okay, we'll just be sending the data as UART0 to 1, right? So this is what we're going to send, and when we transmit the data from UART1 to UART0, we'll be sending the data as 1 to 0, right? So these are the two data buffer that we have declared, okay? So we will be utilizing one of this data buffer depending on the direction in which we want to transmit the data, right? Here we also have declared the receive buffer, right? So whatever data we transmit will be storing the data received in a receive buffer, right? And here you could clearly notice that we have the number of bytes which are present in the data that we plan to send as. So we have 4, 5, 6, 7, 8 and 9, right? So 9 byte. So we have specified the 9 element for our array, right? So we start with zil printf sending data from UART1 to UART2, okay? So this will be from UART0 to UART1, right? So the first statement that we'll be sending on a console is sending a data from UART0 to UART1, right? So here our IP which will be sending the data is the UART0 IP, right? So we call the UARTLITE send function, okay? then we need to specify an instance structure. So if you can see, UART0 device ID is for an instance structure UART1, right? So we'll just be calling UARTLITE send. Okay, instance structure will be UART1, and then the source of a data buffer will be this one, because we are transmitting the data from 0 to 1. Okay, and the number of bytes which are present is 9. Then we will be waiting for data transmission to complete. Now you could see the functions which are present in an UARTLITE are exactly similar to what we have in an UARTPS also, right? And once we complete the data transmission, okay, now here we do not need to configure anymore, because anyway, if you observe an hardware connection, we actually have connected them in a cross. So whatever data we transmit, that will be actually received by the second IP, right? So here we are waiting till our UART2 received all the 9 bit, right? So we again call a receive byte function. Now we know that we need to store each byte in a unique element of our array. So we are calling Rx, okay, and the byte receive, which will be incremented with each new byte we receive, right? So byte receive will be byte received plus the byte which is written by UARTLITE, right? So with each new byte we receive, byte receive will be incremented by 1, and that way we'll be generating a unique location for the new data to be stored in an array, right? So we'll be waiting till we receive all the 9 byte from the UART1, okay, and once this is done, we could say the transmission complete from UART0 to UART1, right? The next step is to send the data that we have in a receive buffer, right? So we just have declared a for loop, okay, and following the same strategy that we adopted in the previous case, we are just sending byte by byte onto a console, right? So this complete all the code that we need to do, okay, to achieve the data transmission from UART0 to UART1, right? So we'll also be verifying whether data is going in a reverse path correctly, right? So here we first send the message sending a data from UART1 to UART0, right? Now our direction of communication will be this one. In the previous case, we are going in this direction, right? Here we are calling a send. In this case, the IP instance which will be sending the data is an UART2 instance, that is our UART1 IP, okay, and then the source of a data buffer is this one, right? And the number of bytes we want to send is 9, right? So we will be waiting for data transmission to complete. Then again we will be receiving the data in the UART0 IP, okay. We'll be storing again it into the receive buffer, okay, and then we mention transmission complete from UART1 to UART0. Finally, we are again sending the data that we have in a receive buffer onto a console, right? So this is a complete application that we utilize to verify the communication in both the direction. That is, when we send the data from UART0, whether our UART1 is correctly receiving the data, and when we are sending the data from a UART1, whether we are correctly receiving a data in a UART0, right? So this strategy you could also adopt if you do not have an hardware present with you. So in that case, what you could do is you could use the multiple instance of an IP and then connect the pins in a cross, so that you able to correctly verify whether the data that you are sending is generating the required response in this second instance of an IP that you have added, right? Once this is done, we'll proceed to build an application project. So once build is successful, we'll select our application project, okay, debug as launch on hardware. So this will automatically program our FPGA. So once our programming is successful, the only thing that we need to do is to connect a YTS terminal to the respective COM port, okay, and click on resume button, right? Now you could see UART init is successful. Now this confirms that both the instance of an IPs are correctly initialized. Then we are starting to send the data from UART0 to UART1, okay, and we do see the transmission complete message, and the data that we transmitted is UART0 to 1, right? So this exactly matches to the test that we are performing. Then in the next case, we are sending a data from UART1 to UART0. Here also we are getting transmission complete. Now the specific reason for adding a transmission complete is whenever your code consists of any error, you won't be reaching over here. So if you have some error in this code, okay, which we have utilized, or whether this is blocking the further execution of a code, that could actually be verified by utilizing this kind of a statement, right? So here we are waiting for entire data to be filled inside the receive buffer. So if our receive buffer or the logic is working perfectly well, then in that case we'll be coming out of this while loop, and then we able to get transmission complete. Else we might guess that something is not working fine with this logic, right? And that way we'll able to understand in our code where the problem exists, right? So here transmission complete, UART 1 to 0, and then the data that we are expecting is this one, because the transmission direction is from 1 to 0, right? So this is how we utilize the multiple instances of an UARTLITE. Now what you could do is you could further explore the other UART IP that you have, okay, that gives you more functionality, such as more operating modes and the ways by which you could add a prescaler, vary the baud rate, and so on and so forth. Okay, so other type of an UART IP, okay, which could provide us more functionality as compared to UARTLITE is UART 16550, right? So on the similar line, you could explore this IP to know more about how we use an UART, right? So this will be providing us more function as compared to UARTLITE.